The signal follower measures the volume level at the location that it's placed in a track or sampler effects chain, and then uses its controls to craft an output signal from that volume input. The output is sent to a destination, which automates the chosen parameter of the chosen effect. The target device is usually in another track or sampler effects chain, since a common reason for inserting a signal follower is for it to allow other elements of a song to react to what the audio is doing here. You may have realised that this is actually side chaining, though obviously this is of the modulation variety and we're not passing along the full audio signal. The set of 3 boxes at the top left are where you set the destination track or sampler effects chain, the chosen effect, and the parameter. There is a limitation though, unlike the other meta devices, which is that the destination cannot be a device that appears before the signal follower, and this takes 2 forms. When targeting the same track or sampler effects chain, the device must be after the signal follower. This is because, as shown in the track effects section of the beginner's tutorial, effect chains are processed left to right, with each device feeding into the next. Likewise, when targeting another track, it must be to the right of the track that the signal follower is in. Although tracks don't feed into each other unless you've set that up, Renoise and Redux do process everything in a strict order to ensure maximum efficiency and as little latency as possible. This is the same for sampler effects chains, except it's applied vertically top to bottom. So, if you want to target a device that appears before the signal follower, then you'll need to make changes so that this is no longer true, either by moving the devices around or reordering the tracks or sampler effects chains. Another important thing to know about this device is that the volume meters to the right are not simply the input and output signals. The left meter shows the value that's been created from the input once it's gone through the input and filter sections, while the meter on the right is the final value after it's made its way through the output parameters. The input options are for changing how accurately the output signal should follow the input volume. Complex waveforms can have large, quick changes in volume, so you may want to smooth those out so that the behaviour of the destination is less jittery. The attack and release parameters set the speed of the response to the rise and fall of the input volume respectively. The sensitivity slider allows you to tune the responsiveness of the device to the overall amplitude of the input. Generally speaking, this means that if the input is very quiet, then low values work best, and higher values should be used for louder inputs. But playing around with this value in conjunction with the output parameters, which we'll come to in a minute, is the best way to customize how the destination effect should be controlled. Since the signal follower is reacting to the input signal in real time, there can be a slight lack of accuracy for very snappy attack rates. So to counter this, the look ahead option can be used to shift this device back in time relative to the audio playback. Of course, activating this is going to add some latency, and this option will only work if automatic PDC is enabled. In the filter section, the low and high pass sliders control the frequency range of a filter that's applied to the input. While the three buttons here allow you to select which of the left and right channels from the input will be used. And it's important to point out here that this device does not actually alter the signal it receives. And so the audio leaving this device will be the same as the input, regardless of what you do with these filtering options or any of the others. The min and max sliders set the minimum and maximum values to be used from the range of the destination parameter. While off will apply an offset to those min-max values. Because of this, if you're looking to use automation to control the general output, then this is the best place to do it. And finally, the scaling option changes how the final output value will be mapped across its range. Normally, this is applied in a linear fashion, but you can also select from two exponential and two logarithmic scales.